Hello everybody, welcome to another stream. How are we all doing? So over the weekend I did a little bit of programming on my compiler and fixed a couple of bugs. I think if you was watching closely last stream, we had a bug where we couldn't reference something inside a structure inside of a push constants. I had to unpack it manually. It was super weird. But yeah, I fixed that bug on the compiler now, which is great. But last stream, we basically finished PBR. I got it looking how I want, except for I've thought about we haven't done this ambient light here, so we might look into that today. But besides that, basically ticks all the boxes, I think. So what we're going to be doing is going over the code and improving, like just cleaning it all up, commenting it. We're going to do some, we're going to try and, we're going to try and also make some example graphics for when I do the devlog, like drawing a bunch of vectors and showing how light will react and stuff, and just how we will explain PBR basically in the devlog, because I think I want to do more of a programmer's perspective to PBR. Just add more content on the subject, really. Should be good. Hey Chandu, how's it going? Good to see you. In your job, you see and work on OpenGL/Vulkan. We use C++. We don't use C. But yeah, we use graphics. I can't really speak much because NDAs and stuff, but we use technologies, if you will. I don't know what way I can say it. Because NDAs, we program against graphics API or APIs. I cannot say. But yeah, hope you're doing good. I forgot to take my my pills. No, it's just some turmeric and a multivitamin. I forgot to take them when I ate my lunch, if you will. So now I'm, yeah. There we go. So yeah, where should we start? I think we should start by, let's start with the clean. Good old clean. We hope everyone is doing good. So calculate BRDF. This function is horrendously wrong. Oh, glorious sir, welcome my friend. How are you? Wow, 13 whole months. Appreciate it, sir. Thank you. You been up so much this weekend? So let's calculate surface color, and look how many parameters are going in here. Crazy. Then we'll calculate BRDF. Look how many parameters are going there. Crazy. We should put them in a structure. Just because, yeah. Basically, functions in shaders always get inlined. Just having a structure just makes it tidier. And yeah, a lot easier to navigate, I think. So right, material, light, and let's got all of these boys and girls. We've got this pre-filter BRDF thing, gradients map, pre-filter map. This is, yeah. I want to change these names as well. We can do that at some point. But yeah, so when see, I think some of these resources should just be, you know what, maybe the structure won't be... So I think these should be global. Somehow. We could put them in the global data structure. No, you want to pass them in though. Fine. And then you need all of the... Yeah, okay, we'll put in a structure. We'll just call it shading. So we'll just move all of these boys and girls into here. And we'll change them back if need be. Right, so in goes the shading strut. There you go. So, okay. Material, light, ray direction, world space. Surface position, world space. Yeah, so we probably want to have more of these in here as well. But these ones you pass in from the outside maybe. And we'll have some more that get filled in when it's calculating the surface color. Adding some small debug things like stack trace into my code base feels good. Awesome. Yeah, it's great when it's great to have that in your program. I think some people say you have a debugger for that. Just hook up the debugger, but when like an assert fires, it's kind of nice just not having to do an extra step to get that stack trace. Yeah, not bad, not bad. Just went and sourced a member of family yesterday. Did a bit, fixed a bug or two in my compiler yesterday too, and yeah, just been yeah, that's about it this weekend so far. Yeah, things are going alright. Been also thinking a ton about this project and what's how to go about things. And yeah, so it's pretty good. Pretty good. So yeah, I think yeah. Just reserve some of that till some future time. Right, so I think there's a lot of dot products as well, where you go like well, yeah, you want to have this kind of readily, like, you want to have this kind of available. Equal count BRDF. Yeah, I wonder, V direction, light direction, half direction, albedo. F0, that kind of needs to be around, passed around. Unless, you see, I wonder what we can do to reduce the amount of parameters. Well, we're just gonna have lighter material there for now. Those could be global. You have to make sure you synchronize on those. Right. Or maybe I should start by bringing some of the stuff out of here, which shouldn't be in here. Yeah, okay. Let me undo this. We'll come back to this. Solve this problem in a minute. Right, so let's go to that learn OpenGL thing. Let's go to the diffuse irradiance. See when they apply it. I don't know if I got something wrong because I'm sure I'm missing the ambient equals diffuse times KD. Yeah, I think I'm applying this one wrong. Irradiance here. Yeah, so I think these need to be moved out. Wait, view direction, half direction. Ooh. N.V, interesting. Yeah. Right. So essentially I need another one of these with the surface normal. And then where was the irradiance? It's that one there. Then I need the albedo. So these used to be albedo divided by pi, didn't it? Was it divided by pi in the end? I think it used to be that. Hey there, Dora, how's it going? Welcome, welcome. I think that was divided by pi. Yeah, divided by pi. So I think all we need to do is bring that back. And then this diffuse. And the ambient light. That's what we're missing. We've got ambient light in the scene. The stuff is behind that's not sort of directly lit. So that'll be KD. Diffuse. We haven't got any ambient occlusion. Right, so I think we need this to actually be outside of this BRDF calculation. And that ambient will then just get added to the final color. No, color equals 0, color. Yeah, the one needs to be emissive. The ambient. So we don't need to pass the irradiance map in anymore into the other one, I think. So our beta is already calculated up there. Right, so that should give us color behind the back of the sphere now. Alright. A little bit, I guess. But then, like, have I messed something else up? I don't think so. Hey Ransel, how you doing, sir? Welcome, welcome. I rely heavily on the debugger usually, but it's inconvenient when I want to debug OS input stuff. Right. Oh yeah. It's kind of real. Yeah, exactly. You do GD. Never seen you do that. Yeah, because I've just been doing like shader programming, basically. But yeah, whenever I do CPU code, I will use the debugger when I want to try and figure out what the code does. I'll put a breakpoint in programmatically with a yeah, the programmatic breakpoint, and then I'll run the debugger. It'll stop there, and I'll have a look and inspect the variables and stuff. Yeah, sometimes I print as well. It just depends on the problem. Yeah, I use GDB. Um, yeah, so I think we're getting some color back there now. You see that's like a bit of a gray shade. Um, no, still very black. Yeah, the reflect ray also needs to. You know what is a good test? Let's switch to day. The reflect ray needs to also be like that as well. A bit messed up. So we switch to from night to day. Let's see if the spheres show up a brighter color at the back. Yeah, they do, right? You see they're here, right? They're actually like a light gray. If there's no light, they look like that. And then as there's more light, yeah. Sweet. So we need to get it to be a bit reflectant or reflective though. So that's because we're missing, or we've got the reflect. Wait, did I multiply the KD by KD in the end? Yeah, I did. Good. The other problem is the reflect, I think. Surface normal view vector. This doesn't use the light, does it, in any way? No. So this can all simply be moved out of here, because this is purely for the lights. So put that in there. And I think we can just add the reflect color like that. Just got to remove the reflect color. Or reflect direction. Let me get that. Okay. So in here there's the... Yeah, this is far less stuff going into here now. Reflect color. Good, so just delete that line there. Great. Right. One of my debug modes is going to get nuked. That's fine. Cool. We can look at those today as well. These debug modes. Right, so now, so we move the roughness down. You should see the environment in the other side as well. Here, where we wasn't seeing that before. Because the only one that was getting the reflective, it was only being reflective in the direction of the light, which was just wrong. Right, it's reflective all around, right? Cool. I can make it more metal. Right, interesting. Hmm. Let me have a bit of a play with that shaded toy that we found. See how it compares to that one. PBR. So, when something is dielectric, you're going to see the... Should we increase that light intensity? Light color. 1, 1, 1. Oh. That's the diagram. Okay, next one then. Light. Still on the diagram. Draw scene light color 2. Right. 5. Right, so you see there's this sort of thing here, right? This yeah, where the light is coming down, it's not able to hit this side. To make it metal, you don't see that line anymore. Okay, that makes sense. So that's what ours does as well. So that's good. Should we switch back to the night mode? Awesome. Right, so here's plastic in the dark. Let's make it basically like a mirror. Yeah, so you're able to see it's reflecting in both sides now. Make it rougher. Let's make it more metal. Make it rougher. Zoom. I love the way it goes with that. Awesome. Yeah, so that's something we was missing. So now this calculate BLDF is for, yeah, only takes in stuff for the light. Purely operates on the light stuff. But then the diffuse. Where's the light direction in here? Oh, is that KD? Yeah, you multiply KD by that. Yeah. So when you have multiple lights, we probably just want to do that once. And then only do this. Okay. That's not bad. That works. So we don't need any of these anymore to be passed in, because they're all done outside. So this is just becomes the material. Metalness. And albedo get passed in. Nothing else is there. Oh, metalness, roughness, and albedo. Is that all there is in that? Shoot, wrong one. Oh, and emissiveness. Okay. Right, so the problem is albedo is probably best to be unpacked because we keep doing it. So it might be best to have like a packed material and an unpacked material. So code just becomes, yeah. Then we just can pass in a strut and then have to do all of this sort of stuff all the time. Surface normal, I guess is okay. Light direction, E direction. See, I guess you could probably put these in a strut somewhere, like in a structure, and F0 as well. Probably material 2. Maybe you can manually unpack. Yeah. So maybe we should make that shading strut now. So I don't know where we want it. Yeah, it should probably be local to this thing though, in a way. So I have that shading data structure. And we'll put in here all the stuff that gets passed around. So I guess we'll have, so we'll have material. This material should be called, there should be 2, right? Shared. Right. We should also, this should be the packed one, and we'll have an unpacked one. So we might make roughness and metalness like a fit into the alpha channels of these guys, if you will, right? And then there would only be 8 bytes passed in, because this is just a 32-bit integer. So, and then this one be the unpacked one. So that, yeah. But this also could be. But yeah, so you'd just be like 32 times 3 times 3. Then you probably want a way to just unpack. Something like that, right? So that'd be returned. Then let's pass in the packed one. So basically the albedo and the material, albedo, emissive, roughness. So right now that's just a direct copy, but you can just change layer. Okay. Packed or roughness and the metalness. I'll just return that material. So inside the global data structure, we're going to instead pass this up from the CPU. And I guess you might have a packed light maybe. Well, we only get the light color once, so I think we can leave that one alone. But yeah, so from the CPU side, we get the material. Let's call it packed. So that's what our sliders operate on. Pass that in there. Cool. So when we so where's this pack? Yeah, so how do we get access to that again? Yeah, it's just passed in, it's global. At the moment. So what you would like to do is say material unpack, and we'll just unpack that pack's material, put it in there, and we'll pass it in. Cool. So in the shading, we could probably just have the material sit in there. So what else is needed in this BRDF calculation? So we need the surface normal. We need the light direction. We need the view direction. We need the half direction, which is halfway between the light and the view. Maybe we should keep those separate. So how about we have a shading and lighting might be separate. Right, maybe you have something. Yeah, let's make another strut. We can think of their names. Lighting. So this one will have the light direction and the half direction, because that needs the light direction and the view direction to calculate it. It's halfway between those two things. So we could say like halfway between view direction and light direction. So that one goes, surface normal. So I could call this like surface instead, right? And then it has a material, and then it has a normal. Or it could be called shading. We then need should I just pass in all these bells and whistles? V direction, ray direction, world space. They're all in world space at this point. So maybe we should drop the world space thing. And maybe just say everything is in world space. We'll put a comment about that in a bit. But yeah, afterwards, I want to pass the shading strut into BRDF one as well. So we kind of need to have like some of these other things, like F0, right? Not the video game, the variable name. Man, that game was good, F0. On the GameCube. Then his sequel. Half direction, light direction, view direction. So they're already in there. We got F0. So n.l will be for the light only. Right. Yeah, so we must pass an n.l in the there's n.h. What about cook torrents? What do you do? It does n.l. Yeah, l.n or n.l. Right. Same thing. Yeah. And it will probably do it Was some n.h in there? Smith geometry. There's another n.l here. What's going to happen? Yeah, we've got to standardize on all this. That's cool. So I think in the lighting, we're going to probably want to have a bunch of n dot. So normal dotted with the light direction, normal dotted with the view direction. And probably the half direction. Yeah. I think those are the ones that we need. So those will also get filled in at some point. So I think when you call some of the functions, some of the parameters get filled in inside the function or something like that. So some of them are in parameters, some of them are just used within. It saves us passing around too much stuff. Yeah. So these are a bit to pass in. These names, I guess we can rename later. So they've got to be passed in. Yeah, I think we'll just make these globally available. Because having them passed in is just a bit weird. Yeah, let's move these into the shared. Yeah, I think there's some things we've got to think about when it comes to resources, because a lot of our resources are just known at compile time and they're just passed in. So maybe we should just move a lot of our resources into being sort of statically known inside shaders, because it's kind of silly passing them into the push constants all of the time. Yeah, I think we can set these then. Yeah. So down here are the globals. Just initialize those guys there. They'll still have to be synchronized on. So maybe we can automate that process if they're statically using shaders, automatically sync on them. You have to figure out that one. Right. So they're just globally accessible now. So whenever we use these now, we can just get all that. We can just say GFX global, and that'll access that global data structure. And voila. Wait, where else is the other one? Oh, it's up here, the irradiance map. Perfect. And there we go. So that's reduced the amount of parameters you have to pass in, but yeah, you definitely need to pass parameters in, right? A material, the surface normal, the view direction, camera. So view direction. Oh, that's just ray direction. Right. Okay. See, the other way would be like you just have the global camera. Oh, the camera globally accessible. And I guess you could just do a ray from the surface position. But yeah, but this then that means recalculating it when it's already been calculated outside the function. So we should just delete view direction, or maybe move it down here because it's just the negate of that. Sure. Is ray direction even used? It's not really used. So why don't we delete that? and have this passed in instead. So we could say this is a vector normalized vector towards the camera from the surface position, right? So that's good. Right, so that's a lot easier. So why don't we get that passed in? So shading will be passed in. Lighting will happen inside. So in goes shading. Right, so shading dot material equals unpack. Yeah, material unpack, that one. Obviously, different objects will have different materials. So for now, it's just a global. But yeah, later that will change. Light. Light will probably just have. We probably won't pass light in anymore. We'll save that one. So view direction is the negate of ray direction world space. Right, I need to get all these actually. Surface normal. Wait, where's surface normal on there twice? Whoops. Surface position. That is simply hit position in world space. Surface normal. Normal in world space. Nice. So instead of doing all this stuff here, we simply just pass in this data structure now. So I can probably just do something like that. We'll move the light inside, we'll save that one for later. But yeah, instead of passing all this in, it's just now shading. And that will get passed into the internal functions as well. So let's bring this in here. So I'll put lighting here, and we'll look into that in a bit. Or light rather, lighting. Light color, go down here as well. Sweet, light direction, half direction, nice. So basically, we would like to say, hey, this is in world space. Right. World space, world space. Obviously world space. Whatever. Nice. So we want to say like these are, so input parameters, and then you'll say these are calculated internally. Ignore these. Well, no need to pass these in. They are calculated internally. Cool. So with the lighting, we've got a similar thing here. So n.l, normal.light, normal.half vector. I guess I could comment that too. Right, normal dot light normal direction surface normal, I guess. Let's plug all those boys and girls in. So this is the half direction. And then the v direction. Wait, n dot normal dot view. Why would that be in lighting? That is probably better off in here because it's light. It's independent of the light. Cool. That's really great. I would tell you which language I'm using to write my rasterizer, but you should not ban me. No. Oh no. Is it Python? Yeah, Racket, huh? Heard about Racket. I forgot about it though. It's alright. You'll not be banned. You will be forgiven. You can write in C afterwards. C sharp? C sharp? Yeah, I used to use it for my job as well, back in the day. It is too hard, fair play. It's just, yeah. You just gotta get used to pointers and allocate memory. But yeah, that's cool. Yeah. But at least you're giving it a go. That's good. Yeah, C sharp though. Interesting language. They have like if you have a class or a strut, like a class, is always like basically heap allocated, if you will. Probably in some object pool somewhere, but it's heap allocated. And a strut is always by value. So a class is by reference, a strut is by value. And you can, with a strut, you can pass it by reference if you use the ref keyword when you have a parameter. But yeah, I thought for years, I didn't know what to think about this for years when I was a beginner, more of a beginner programmer, because it was my first job doing C sharp. I was unsure if this made any sense. But yeah, it doesn't have any benefit in any way. It's just quite dumb design. Yeah. They've got like a lot of features in the language, so you want you defer. Yeah, I know, right? Go-tos do the job, but yeah, defer would just be the clean way. You know. Press my F0. Shading.f0 now. Look at that. Albedo doesn't have to be unpacked anymore. Boom. View direction. That's already calculated and passed in. Boom. N.L. Why are you here? You're in the lighting situation. We'll get to you in a bit. Emissive, that's when you unpack the material that's already in there. KS, view direction, so it's be shading, shading, shading.material. So material could just be passed in separately, because I was doing shading.material.melness. So I think for sanity of the line width, I think we should probably pass in the material separately. That way I can just say material dot. Oh yeah. So I can see the cleaning up just collapsing. Now it's so good. Well, that mess just collapsing. Again, notice by professor if I use goto, so pain. Damn it. Yeah. Yeah, I guess you can try to avoid it, but sometimes it's just required. Like the most common use case is when you open up a file and want to read in the whole file into some memory, and if it fails, you want to close the file and return an error. And having gotos then to do the cleanup to close the file handle is yeah, it's definitely much better. Right, so this could be our ambient. So I think we'll just do something like this. So ambient, calculate the ambient light. This is the reflected light. So shading n.v, max shading surface normal, shading view direction. Yep. Pretty nice. Albedo, that's material at albedo. Yeah, how's the software triangle rasterizer come along, Chandu? Have you got the PNG output to file yet? So reflect, we want to get the reflect color. So this would be the color of any reflected. Yeah. So on the reflect ray, what is the color? Yeah, this needs a bit of a tidy. So you have a reflect direction, which is right. That needs the radar. That actually needs the ray direction. I guess you can just negate the view. That's fine. Shading dot view directions. That's the ray direction from the camera. But hey, surface normal. Then we want to do a right, samples the BRDF from that texture. Shading dot this. A lot of parameters. I guess we can do this. I was using a built-in class in C#. The C# gave me awesome. I was figured out how to draw a PNG. C# did that. Nice. Let's have a gander. Drawing path. So you've tested with putting some graphics in there, awesome. And then you just do PNG, save it out. That file path, cool. Awesome. So now you've got to do your own version of this. You got this. Yeah. Awesome. Yeah, completed it. Yeah. It's cool. Um, right then the reflect color is by sampling pre-filter map, which we're going to change that name. Don't you worry. .rgb. Then the reflect. Right, so this is the Fresnel. Let's give that a separate one. Fresnel. Something I want to get rid of is that Fresnel non-roughness version. We'll just have it with the roughness. Yeah, then you want the V shading. Yeah, shading.f0, shading.n.v. Cool. Fresnel. The Fresnel reflectance. Then you want to multiply with a BRDF. That's still the BRDF. Yeah, so this is like the shadowing. Wait, what is it called? Geometry shadowing function. Yeah. Oh, yeah, maybe we can encode that. Because basically, right, we're just multiplying the Fresnel with this one here. Can you see it? And this is n dot v. Ah, it's got the material roughness in there though. Right. So we didn't do the roughness version of the Fresnel. We could encode it into this pre-calculate BRDF basically. That's cool. Right, say we didn't use the roughness. You know, we'll look into that later. There's some optimization. It does make a distinct difference. But yeah, okay, let's leave that there. So that's all cleaned up now, that's good. So with the lighting now, so this is where you probably do like a for loop over every light. We don't have lights. We can do lights though. But we'll make it lights in a bit. So we'll have this overall sort of so I guess we can call it light color. I don't know, because you've already got light color. So this be your diffuse. And your specular multiply with the light color. Should I call it radiance? Maybe that's more correct. Ambient radiance. Because that's how much light is being emitted. Yeah, that's correct. Along a particular ray, and the ray being our view direction, the direction towards the camera, that pixel. So maybe we should call this This would be the light radiance. Then that would be light radiance is equal to this one here. Multiply BRDF light color n dot L. Awesome. So that's where the light color will go, light radiance. So you have your outgoing radiance here. So noise. Material dot emissive radiance reflect radiance, or reflected irradiance, if you will. Right, that is good. So right now we want to call this BRDF stuff properly. We didn't need these parameters anymore, but what we needed is the F0, the half direction, and yeah, so we need the material, the shading, and the new lighting data structure, which we've got to fill in now. So the shading data structure, which gets passed into surface color with the material. So we need to fill in this thing. So there's a light data structure as well. We could pass in that one too separately. So lighting dot light direction. Why? Oh, light dot direction. No. So light direction doesn't need to exist, but we do need. Well, the reason why you have a light direction separately is because you might have different types of lights, I imagine. So maybe we'll put all of the light parameters in there. Yeah, direction and intensity. Yeah, okay, I changed my mind. So what we're going to do is we're going to pass in probably the radiance, light radiance. Like that. So that'll be the color multiplied by the intensity. You'll have the direction. Yeah. Nice. Yeah. So radiance is going to be the color. Wait. Yeah. You have the direction, which is lights dot direction for now. In the future, if we add like different light types, the direction will probably be different. I don't know, we'll see. Half direction, halfway between the v direction, shading v direction, and the shading light direction. N dot L, lighting n dot L, lighting n dot H. So shading, this is right around. So shading, lighting, light direction, lighting, half direction. Ooh. Is lighting a little bit long of a name, maybe? But yeah, they're all filled in there now. So basically, when we say calculate BRDF, we pass in the shading strut, the material strut, and the lighting structure. And we've got to adjust the internal code to use that now. But this gives us back a BRDF, and then we can use, well, we could just say calculate lighting. Light radiance. Yeah. Well, yeah. So calculate BRDF, maybe that's different. See BRDF here. Maybe we'll split this if we need to, but for now I think this does it. BRDF. Then return that value there. Yeah, I would love to make sure we keep this viewing mode stuff, because I think when I do like the devlog, it might be useful, but we shall see. Let's comment out for now. But yeah, so for that shading strat, so let's plop those there. So these are all filled in from the outside. Good. Right, so calculate lighting or light radiance. So shading, material, and lighting. Nice one. Cool. Well, yeah, I wonder if we just put it all in the shading strut and just be done with it, you know? Let's just leave it separate. Right, so they've got the Fresnel here, shading, lighting, half direction, material. So you got those two there. Calculate this thing called alpha, which is the roughness squared. Albedos doesn't have to be unpacked anymore, so that's just material.albedo. It's the Lambert. So then there's diffuse. That's calculating the diffuse. Specular is just cook torrents. So cook torrents doesn't need all of these. So we've got to dig in to figure out how do we reduce those parameters too. So let's hop in here. So let's go from these guys. So cook torrents is the specular term. So basically it uses three things, right? The Fresnel, which gives you, I need to relearn what it gives you exactly, but it gives you, yeah. I think it's how much the light is, how much light is reflected towards your view normal, as a percentage or a ratio. You got the Smith geometry shadowing function, which is how much light is not reflected in your how much of the light is not reflected towards your view direction, basically, following the based on how rough it is, basically. And the GGX Trowbridge is that specular highlight, that normal distribution function. So That's this guy here. Normal distribution for now. This one is not really correct though. They've shown us the wrong for now. F term, the amount of reflected light for a given substance. It approaches 1 for glazing angles. Right. Yeah, the percentage of microfacets reflecting light in the given direction. Yes, it gives you this. The shadowing function, the amount of defines the shadowing of the microfacets depending on their arrangement. As it gets rougher, the microfacets, it gets rougher. That. So it's just a bunch of statistics basically. You don't actually simulate the, sorry, you don't simulate these microfacets on a high detail. It's just all some maths algorithm that just that does like an approximation. So I want to look into these boys and girls, normal distribution, n.h. So I've already made that one better. This is fine. This one takes in a surface normal x, and it just uses them to do a dot product. So what you really want is an n.x to be passed in. And the reason why it's n.x, because x means anything. And it's used for view direction and light direction separately. So that goes there. And then we can simply so what we would like to be passed in here is n dot v and n dot v, and wait, what am I doing? N dot l. Nice. Right, so that's the geometry done. Fresnel Schlick. So for the Fresnel Schlick, yeah, I would like it to be like this one with roughness, but we might move to the roughness only one. I just want to get things up and running again before we do that. So we get rid of these two parameters. Right, n dot v in this one, but this one is n dot h. So we should really call it n dot x, and it's just whatever's passed in. V dot half. Interesting. All right, we'll just say dot. x0 dot x1. Yeah. So view dot half direction. Is it really the view dot half direction? I'll double check that. Where's the Fresnel? View dot half. Okay, it is. Gotta remember that. So let's do that quickly. So we don't really have a view dot half here. It was like torrents. View direction dot half. So we've got to fill that one in. View. Nice one. Yeah, so we're gonna do that for now. We want to pass in the shade lighting dot view dot half. There we go. Right, so that won't get messed up now. Yeah, so nice. Cool. So in the cook torrents, do we want to pass in the lighting strut and stuff like that? Like what stuff do we need in here? So you got the surface normal, which is in shading. Right, let's resolve these guys. So these you need the lighting n.v n.v and then v.l. This one you just want the n.h. And yeah, I've already got these calculated. So that is normal dot view. Lighting normal dot view. Lighting normal dot light direction. So there is a surface normal here, but that was only to calculate this. But now that is, it's gone, isn't it? And also I'm a bit confused why I wrote these out the other way around. Oh no, it's probably fine. Yeah, so now we just need to pass in lighting. Lighting strut only. To that one. Well, oh, we need F0. Right, F0 goes in. So you need alpha. And then you also need view.h. n.v n dot h n dot l. Well, yeah, all we've done, I guess, is just done some optimization, if you will, but the compiler probably would have done that anyway. Yeah, I wonder where we should pass in the structures though. Because the problem is the alpha wouldn't be filled in. Alpha could get filled in while we do the lighting though. So instead we could just pass in shading. You know, yeah, but keeping these outside of those shading struts could just be better. Oh, did I just undo all that? Damn it. Right. n.h n.v n.l. Right, we'll pass all those in manually, that's fine. So we'll remove this whole lighting thing. Right, nearly there, I reckon. Gotta plug them in here now, so... Oh, shoot. Eh. It's really, like, cleaned a lot of stuff up. So, alpha... No surface normal needed anymore. So it's all just lighting, dart, and then whatever these guys are. So... let's just repeat that. n.l, n.v, n.h, and view.h. Cool. So BRDF lighting dot. Right, I think we're basically there now. We should be able to get things up and running again, and then we can take do another sort of thing to clean up, like probably just rename a few little things. But I think we're getting close to the end of the cleanup though. Oh, that's shading, I think. Send me my Fresnel. Oh, the Fresnel. Wait, what Fresnel did I change? Oh, I changed the Fresnel. Which one was it? On the cooked torrents. Wait, where's the two Fresnels? View and a half. Ooh. Lighting view dot half. Wait a minute. So, where's the Fresnel and the cooked torrents? Another view dot half as well. Interesting. Where's the KS in that in here? KS and KD. Um, the- um, this one doesn't use that KSKD thing. Well, maybe it does, but it's... maybe it's pre-calculated somewhere, I'm not sure. But yeah, so that Fresnel's calculated twice then. So KD Lambert albedo divided by pi. Diffuse color, is that the yeah, base color? So the other place we do the Fresnel is here. Let's end normal dot view. It's a different one. See, that Fresnel could just be set in the lighting strut and then passed in. So that's just KS. So KS is not used here. It's just used to get KD. Yeah. So we should probably in the lighting strut do a KS. Do we need input parameters? Well, I guess. So you might need to actually pass in the light direction. The rest could probably just be calculated internally, I think. Followed by the KS. Something like this. So I think we could just get all of that. Go to here, drop that in here. So filling in all those, lighting, yes. And then we also need a lighting KS as well. Lighting KD we don't really care about. Or put in a structure at least. Well, it doesn't need to be in a data structure, I just realized. Because we're not passing this data structure around anymore. Yeah, you know, we'll make these all local variables and just get them passed in. Yeah, that's just probably a bit easier. Okay, no biggie. So these are all float 32 times 3, and these are all float 32. So some of the lighting stuff will have to get removed, but that is okay. Just like that. There. So half direction though. Half direction. Yeah. So those will go. He's passing those two data structures there. Right. Well, those two fields there. Okay. That's better. Right, so can we get that compiling now? View my direction. F0 shading dot n dot v. Does it not have an n dot v? N dot v right there. Light color. That is radiance lighting. Albedo. Right, it's material albedo. Shading.f0 now. The Fresnel takes in the dot product of those two. View.normal. So that's already calculated. Shading.n.v. Right, nearly there. Just these boys and girls now. So what's been complained about here? Right, it's not called color anymore. Radiance. And there we go. So hopefully that still works. Yeah, so still support a bit of transparency in there, so we're just doing that for now. What? Oh, there's no alpha field, is there? Right, I'll just put it as 1. We'll come back and do transparency in the future. Okay. So hopefully it still looks exactly the same. Let's see. Rightio. So we don't have ways of viewing the different things anymore. Right, there's the metal. Bring the roughness down. So this is obviously plastic that's not very rough, it's pretty reflective. That looks like it's the same. I can see the Fresnel at the side. Right, it's definitely brighter at the edges. As the roughness goes up, that goes away, that's fine. Metal, that, yep. It gets rougher. Hmm. Yeah, it's looking alright. So let's put up the light intensity. Yeah. Hmm. Yeah, I'm not sure if I can spot anything that's wrong. We should definitely get the debug modes working again, though. Yeah. Right, so that's good. That was a really good cleanup. Now things are just a lot more easier to read, basically. We can try and add multiple lights. That'd be a bit of fun. We can have a light that maybe moves or looks like it's moving. That's it can have different colors as well, and then we've at least got multiple lights. So it's a little bit more correct there. Yeah, let's do that next. That'll be a bit of fun. And then I guess we do the debug modes as well. Yeah, you get some new debug modes. Right, I'm just gonna take a quick break and then we'll come and do that. Right, Billy. Hey, welcome back. How's it going? Thank you so much for the raid there, Auntie. How you guys doing? Welcome, welcome. Um, how did the stream go? So we're currently working on cleaning up our PBR code. So we've implemented physically based rendering into the code base, and we've just been tidying things up, making sure they're correct, and yeah, we're going to be adding multiple lights now, so we'll add a couple of lights. So we're going to test that out. And we're going to probably correct our debug modes because these don't work anymore. Because I want to try and prepare making a video which basically goes over how I did PBR. So I want to prepare for that. And yeah, so this is what we've been working on. Hey Alex, welcome back. How you doing? But yeah, I hope the stream went well. So we're adding multiple lights. So we have lights being passed up from the CPU, or light being passed up, a light being passed from the CPU. So we're gonna have lights. So have two. We are going to then set them up with a color of white and maybe a color of, I don't know, keep it white. Well, we could have a moving one. Let's do a teal one. Teal's a good color. Same intensity, direction. So what I would think we should do is probably use the time variable and make it so that it's pointing down, but it will move like that, simulating as if the sun is moving like that. So it's like a directional light. So we'll just do something like that. That should be good enough. So that'll be like 1. So we'll just say point. Oh yeah, we didn't point in the direction. So up, and then the X, if you will, I think will change. So that'll just be, yeah. So time, sine. Have we got time? Right, let's move this to the top. Yeah, hard-coded delta time, the best. Yeah, so time in seconds. Let's just plop that in here. And voila. So sine will make it go from 0 to 1. Or -1 or 1. So we need to make it go from 0 to 1. Oh no, we did it. -1 or 1. That's what we want. Cool. Good. So now in our UI, we actually have the ability to change the lights. So the light color and the light intensity. I think we'll just change the static light. So we'll just have this one configurable. The other one is not configurable. But we can maybe change that if we want to. But I don't think we want to. So, right. So now regarding light, we want to make sure in our global data structure there is an array of lights. So it's just 2. So we're just going to copy those in there like that. And then in our shader code, we get access to the lights here. So I would like to do a for loop over all of my lights. Core array count. Shoot. Wait, I can't do that in shader code, damn it. We'll just hard code it to 2. And we'll light index. Right, so the thing is now, we're not accumulating the light. So I think we need to, I think you accumulate it. So initialize to 0, and then we're going to say, hey, add the result of that light to the overall light gradients. So let's give that a go. Let's see how well that works. Right, so we are getting another light moving across the x-axis as we expected. It's blue. Pretty cool. I would probably like to change probably make the intensity something that we can, wait. Oh yeah, it's fine. Fine. So the light is directly above. But yeah, that's cool, that's cool, that's cool. So we should probably make the intensity actually configurable. Yeah, we'll just copy paste the UI. It's all temporary anyway. So 1, 1, and 1. So now this is all configurable. We've got another layer here. So I could probably get the name to be better, to be honest. But yeah, I can jack up the blue one. So you're really seeing how it is just going across like that now. Nice. And then I can also just change the color as well. Green is way brighter, as you can tell. Yeah, it's really cool. So we're getting two sort of, for the more plasticky, you're seeing that like that, which is quite nice. Yeah, two sort of, yeah, two lights. I forgot what you call this, where it's sort of the light ends. But if we, make it metal, that will disappear. You just see two specular highlights. Sweet. Pretty cool. Zoom. And then that's it really rough. Zoom. I love that effect. It's great. Yeah, metal is metaling. Doing a good job metaling. Vroom. Get an enhanced version. Zoom. Anyway. That was a nice addition. I like that. What should we do? What should we work on next? There was that Fresnel roughness. Where the Fresnel, there's a roughness version of the Fresnel. You know what? I should really get those debug features back in. So we have this thing called a view mode, and it's a drop down. And you say, hey, view the diffuse, specular, normal distribution, Fresnel, geometry. That isn't probably a good way. I got it from like this shader here. I was like, wow, this is really cool. You can view them independently. But then I realized that actually the Fresnel is not, the way he plugged it in this example here, uses the environment Fresnel 1. So it's, yeah, it's different. It's not using the cook torrents for now. So yeah, I think I want a way of viewing a lot more things. So we should probably have a way to view like the ambient, the reflectance, the reflected radiance. Man, this is so much cleaner. I'm happy about this. The reflected radiance, the light radiance overall, and then light diffuse, light specular. Yeah. So just add in some more things. We just need a way of doing that. So I think we need to move it. The problem is with the lighting is we're going to accumulate all the lighting now. Hmm. So when we do the debugging, is it really going to be useful viewing all the different versions? Maybe. Yeah, I got to remember this one does the n.l, isn't it? All different contributions. Yeah, I think it would be. We'll do it outside, I reckon. So what we would like to view the ambient lighting. We would like to view the reflected lighting. Then light slash diffuse, light slash specular, light slash normal distribution, light slash Fresnel. I think these are really specular. Or maybe you should call it or diffuse lighting. You know, there's that Fresnel that we calculate here. Yeah, that one's fine. There's a KS n dot v. Oh, this could kind of be shared. So we can maybe have the Fresnel n dot v, and the other one is Fresnel view dot h. Yeah, we wanted to have those. You see, those are basically these are identical. We should probably move either stick with the Fresnel-Schlick roughness version or just the Fresnel-Schlick one, which doesn't take roughness into account. We should probably use the roughness one, but if we didn't use the roughness one, we could bake. Actually, baking it into here is not good anymore because it can actually be used to have this ambient calculation as well. Interesting. But yeah, so there's KS. Maybe we can actually get a bit of KS here. Oh, it's a different KS from the other one though. Normal.vu. Let me double check that. Learn OpenGL tutorial. Yeah, normal.vu when it. Yeah. Same with the. Let's have a look here. Where's the Fresnel at? F. Normal.view as well. AS is F, yep. Alright, tons of ambient occlusion. You don't have ambient occlusion at the moment. That's interesting. So that would be... Yeah, it's fine. Right. I got an idea now. That's good. So what about this lighting radiance thing? The Fresnel is here view dot half. Right. So ambient and then reflected. We could just call it irradiance. And then a diffuse irradiance, and then probably specular irradiance. So that's like the reflected. Maybe we say diffuse, specular, and then one's from specific lights. Yeah. Probably have the Fresnel as well. And then this one debugs the particular lights. Yeah, I think that's what we want, is those viewing modes. So now we've got those in, we need to actually put a nice switch statement in. And we can just hard code it probably here at the end. So we just want to do a switch statement on, well, we had it in the calculate light radiance. So, oh, and we still have it in there. So maybe, yeah, I think we'll have this switch statement repeated. So 0 means all. You're just going to do nothing there and let it just carry on to the end. Then we've got diffuse. That would be, yeah, just be ambient. And I'll be with the front now. I don't know, we should just call that ambient and then reflected. And for now, maybe. Cool. So ambient radiance. Bear in mind that is not. Maybe this should always return a vector 3, right? Because it's just silly. Yeah, we can make this do that here. Color 3 or whatever. And then you have a color, like a proper color. Cool. So calculate surface color. So we're going to return the ambient radiance for 1. For 2, that is going to be the reflected radiance. Then the 3 is going to be the Fresnel. So for the Fresnel, it's this one here with the roughness value. So put that in there. So for the rest of them, I would like to say that I would like to say 4, 5, 6, 7, sorry, and then an 8. 4, 5, 6, 7, 8. For these guys, we would just want to return the light radiance, and then what we're going to do is that is going to be properly handled inside when we calculate the light radiance here, and then it'll just get accumulated for all the lights that we have. So we'll still keep this one here. So what we're going to do is just ignore I guess we can just say if it's 0, 1, 2, or 3. 1, 2, sorry, 0, 1, 2, or 3. Then these ones here, 4, and that we do what we used to have. So the diffuse, it's just diffuse, isn't it? Then 5 returns specular, and then you've got normal distribution. This is Trowbridge rates. So that's the little specular highlight. N.H, we've already got N.H. Then you have the 7, which is the Fresnel. So that is KS. Fresnel there. Then return then for 8, which is geometry. So that's the oh yes, the one below here. So this one's a geometry. Alpha ray, we need alpha. N.V, right. So basically, I guess you break there and you just return that normally. If we just put this in here, that should be all the debugging modes. And so we should be able to just quickly debug and make sure everything's the way it should be, but it should be fine. So now what's pretty cool is we can see those debugging modes. So we've got view, we've got ambient, this is the ambient light. So you'll notice that hopefully, yeah, it draws the, yes, the ones at the top are dark, a bit darker, slightly darker. How's a way we can tell this? If I take a screenshot, we've got a texture viewer. I've taken a screenshot. In the texture viewer, we can change the black levels and the white levels, so we can bring up the bring down the white, and you should be able to see it a bit easier. But it is slightly darker at the top. So yeah, that's cool. So yeah, that one, that makes sense. And that's because what it's doing is spawning, well, yeah, it's the ambient light from, it takes the surface normal and it gathers all of the rays across the hemisphere against the environment map. So the top, you've got a lot of dark sky. So I guess you could get some of these buildings that contribute to it, but you got a lot of night sky there. And same with this floor here, you should hopefully get darker at the bottom. But I think that's all right. It's not dependent on the light direction, which makes sense. Reflected light. See, it's just the reflected stuff. Wait a minute. Do we monkey around with any of these? So if you monkey around with the metalness, I guess you see a change. Roughness, not so much. Wait. Yeah, roughness, not so much. You're getting the data from the image and doing reflection. Yeah, that's in the reflective one. So this one will be... wait, where is it? Yeah, so the metal it is, the more reflective it is. The rougher it is, the more faded out it goes. Zoom. What? Doing this and doing reflection? Well, this one here? How do you know how much light comes from it? It's just... Oh, what am I even doing? Monkeying around with too much. Like here and that. Yeah, so the problem is this isn't correct. You see how much brighter that is? Yeah, so that's probably okay. Yeah, it could definitely be brighter. Maybe that's something that we could look into. But it's nowhere near as... If I turn everything back on, you see these specular highlights here? These are the lights, which we can't see because I haven't got any rendering code for that. But the lights which are illuminating the spheres. These ones are brighter than those over there. Because their values, their intensities, put them out of the sRGB color space. They're brighter. They're much brighter. So you do that with HDR. Yeah, I have my own lights here, yeah. So if I have a HDR environment map, these could show up brighter, although maybe this intensity should be higher though, because but then again, this environment map is meant to be infinitely far away. So yeah, something's a bit off. Maybe let me double check a shader just quick. Pre-filter map. Render pre-filter map. We gotta change that name, it's a horrible name. I hate it. sRGB to linear. We did convert it to linear. Yeah. Seems like it's alright. I don't know though, it could be a... Maybe it's fine. You don't want it to be too bright though for reflection also. But yeah, let's go back to... Yes, you still see their reflection though, which is nice. Cool. So let's go back to these debug modes. We've got Fresnel. So there's that Fresnel. So you got this one is based on the directions to the camera and the surface normal. So when it gets at the edge, that's when they're perpendicular, so they glow. Wait, is that right? View dot, yeah, it's view dot normal. Yeah, so this is for reflected light. So you might want to call this the reflected Fresnel. This is for reflected rays when they get the perfect bounce into your face. And if you change the roughness, this will slowly fade away because the reflected, you know, you don't really get that perfect reflection anymore. The rougher the surface gets. Light diffuse. This is for the lights. Diffuse though. Shouldn't this be at least n.eld? We need the n.l, I think. It's right here, isn't it? Or I don't want it pre or post n.l. I think I want it. Cartoon. Yeah, some of them do look like cartoony. Yeah, we should probably n.l the thing, is that right? Or maybe not. Maybe we shouldn't n.l the debug modes. So that's the specular contribution. Why am I seeing it colored? Right, is it multiplied by light color yet? Interesting. Light diffuse. Yeah, maybe we should wait. Yeah. Normal distribution. Then the Fresnel. That's different. Fresnel, this is view.half or something like that, the half direction to the lights. It does change. Yeah, part of me is thinking we should, and the geometry shadowing. Yeah, this one you can really see. See, I wonder what they do in this one. Diffuse. I made the light really bright, didn't I? But they shown the n.l on that. Saturate. Yeah. n.l. Right. Maybe it does make it easier to debug these things. Yeah, so I think what we should do is have the final color or the radiance. Oh. So that is BRDF. There we go. So then here we'll say radiance equal diffuse, specular, Trowbridge Wright's, Fresnel, geometry shadowing. Then we'll plug that into there like that. And so they'll have the n.l, so we should at least see the lip, if you will, where it changes from. So we go to now light diffuse. This is the diffuse contribution. Should we see color? Probably would be nice to see color. Did they do like a light color in this one? Do they view the light color? Yeah, I think it would make sense to do it. Let's do 5, 0, or 5, 2, 3, I don't know. Yeah, you see the color in the debug there, that's cool. Let's do the same thing. So to get the color, we actually need to multiply. Wait, multiply BRDF? What? Is the color calculated outside here? Oh, it's here in it. BRDF. Yeah, why don't we just change the BRDF? BRDF. How did it fix the Fresnel? Boy, what from a few streams ago. Holy crap. There's breaks in there. From a few streams ago. We had the problem with the Fresnel was that kappa. So if you're referring to that one, what happened was I was using this. The Fresnel function was fine. What I was feeding into it was okay. There's two types of Fresnel basically, and I got confused. We'll go over it in just right. That's good. So basically, yeah. So the more perpendicular the ray is, let's go to the Fresnel. This is the one I wanted, right? This sort of glowy edge one. So when you shoot a ray through the screen and you hit the surface, and you get the surface normal, you're basically doing the dot products between the normal of the surface and the camera ray. And the closer that is to 1, the more white it is. So obviously the edges is where it really shines in this case. So that's the view dot normal. Well, we were trying to. Why I thought my Fresnel was wrong is because for the lighting, what you want is the view dot half, which is with the half of the which is with the light vector. So this one shows. Let's see if I can draw it out. So I'm gonna have to do some. I think we'll start these today actually, but I'm gonna be doing some 3D graphics like vectors and stuff that I'm gonna use in my devlog. So I think I'm gonna program some of those today to really demo some of this. But basically, if you have your surface, let's do a better surface. I don't know. What can I draw? Right, so you have your surface, you're trying to light a little pixel on it. And you have your camera over here. Ding. So the Fresnel is telling you, so you got your direction towards the camera, and you have your light over here. Ta-da! And there's that vector there. And then if you get the average of these two by adding them together and normalizing it, you get the half vector. So basically you do a view dot half vector. So this will And then I guess you do a 1 take away the result of that. I think that's the way it works in the Fresnel. So the more perpendicular these guys are, the brighter this light is going to be, basically. So how much of the light that comes from here does it perfectly reflect in the direction you're looking at? And that's the reason why that Fresnel doesn't give you the ring around the outside of the object, because it's not using the surface normal in any of this, right? It's just using the light direction and the view direction. Does that make sense? So yeah, it's just how perfect does the light sort of just bounce off in that direction into your, yeah, because obviously if the light is up here, it wouldn't be perceived as bright as if it was a perfect reflectance. Yeah, so that's the reason why this Fresnel looks different to the other one. And then you've got the, right, so you got the diffuse, specular as a whole, then specular normal distribution, then you got the Fresnel on top, which is saying how well that reflects into the camera. Then the geometry shadowing. This one is saying how much it's being shadowed along the light and view direction, I think, something like that. And then that all combines into this one. So that's the reason why this becomes less. So that's it as a very raw value, but when you combine all those three together, you get this one. Cool. So I think that's in a good place. I don't know how much I want to use these for the video. I got to think about it. But I think this is a good place to commit the code, and we can move on to basically doing debug drawing to explain how this code actually works. Oh, wait. There was one more thing I wanted to do. I wanted to move to using Fresnel roughness everywhere. So Fresnel Schlick, there's a roughness modification, which will make it, as the roughness goes up, it will just make it so that there aren't those perfect reflections anymore. The rougher it gets. So just double checking these are basically the same, and then I'll just replace them. That's exactly the same. Something dot something else. Something dot something else. Multiplied by FR. And then add this. So FR is already this expression here. So this has just changed out for a one take roughness, so invert the roughness. Give me a max. And then subtract that from this one, okay. Yeah, that's a drop-in replacement. That's quite nice. So let's go ahead and just remove this roughness thing, roughness suffix, and let's go ahead and actually just replace it. Wait. X0, X1. Right. So let's go ahead and find all these and replace them. So we actually need a roughness in here. I wonder if alpha will work better, because alpha is roughness squared. Let's plug it in there and we'll have a play around with it. Let's see. So you got the Fresnel here. Just plug in alpha and let's just see how it behaves. I don't know if there's an alpha. It might be. Right, so I think we're switched over to that. Oh yeah, they don't want to use the roughness version anymore. And there's some of them are using this passing in the roughness value raw. KS for now. Alright. Alright. So let's give that one a go. Things still look the same. Kinda. So basically, if we look at the Fresnel, as the roughness went up. Right, so it doesn't really change much, gets about halfway, then it really changes. So if we did 0.5 times 0.5, that would have been 0.25. So I don't think squaring the roughness is a good idea. So wherever we do this Fresnel thing now, let's actually just put it back to being proper roughness, not that alpha thing. So we actually need to have the roughness passed in here. Now, do we use alpha anywhere else? Right, okay. So we'll pass in the roughness. So material.roughness. F32 roughness. So in the Fresnel, put the roughness in there. Right, so let's go around and quickly place this all with roughness again. Material.roughness. Material.roughness. And full circle. Nice. So now let's go back and have a play with those changes. So we see the Fresnel here, that reflective Fresnel. Maybe we should call it reflective Fresnel. 2 seconds. Hey. Okay, I'll go get it now. Okay, bye. Right, 2 seconds. My wife just called me. Just popped out. I need to get the baby monitor. BRB. Right. Got the baby monitor now. Keep an eye on the boy. Yeah, so for now, let's watch when we change the roughness. Yeah, it really slowly disappears now. You can see it. Yeah, so that's what we want. Cool. So what we should see is when we do the reflective one. Yeah, you see you have the Fresnel here, so it's brighter there. Gets way brighter there, doesn't it? Cool. Nice. So what would it also change is the Fresnel in the light one. So we make it, the rougher we make it, the less, and I can't really see much of a difference here, not gonna lie. Oh, I see it pop over there. So that one has the perfect, yeah, the light comes from, not really. Yeah, the light comes from that way there. So maybe, yeah, maybe over there it's getting a good perpendicular. Oh shoot, what am I doing? Yeah, I see a bit of a change. Cool. Wait, why is it getting brighter? Yeah, it gets brighter as it gets less. Good, 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 good. Masters in computer science? No. I went to college and then wasn't very good, so I left. I got a job through college though, so I just stayed and did that. And it was in C sharp. C sharp dev. Right, I think we're nearly there. I did see this being used here though. Smith geometry. Yeah, this does look like the Smith geometry. Let's have a little gander. Let's bring this and just see if that is the same. Or similar. So square root, it's your square root though. It's very similar. Yeah, it's similar, but it's not the same. That's cool. Right. So I think we can do a super lovely commit there. What I would like to say is clean up PBR code. So now yeah. Awesome. That was a good clean. How did you get into graphics though? Yeah, hobby projects. Thank you, appreciate it. Appreciate the compliments there, Kappa. Yeah, I just, well, just, yeah, I worked on my own stuff in my spare time. There is a lot to learn. The more you surround yourself with people who already know a lot of stuff, the better you're going to learn. That is just a fact. So if you can land like a junior entry position somewhere, that will help you a whole lot. If not, you follow tons of people on the internet who know a lot more than you and learn from them. And don't just follow one person, follow many people, because everyone has different pieces of knowledge and different perspectives. And you need to, you know, gain, some people would just, you learn better from. They're just more compatible with the way you learn. But yeah, it's all possible. It's just a lot of work. But yeah, it's all good fun though. But yeah, definitely try and start simple where you can. Yeah, this is why I've been trying to say to you, work on that triangle rasterizer, because when you use OpenGL, it will just feel like some system, some system you don't really currently look into. You're like, how does it do all this stuff that it's doing? And you won't be able to you won't be able to think about how it is achieving what you are telling it to do. So the more you know about how the systems work that you use, the better you can solve the problems that you want to solve, basically. And it's a nice simple way to get into graphics programming. Run a software rasterizer. I wish it was the way that I got introduced into graphics programming, because I just learned OpenGL and I was confused for years on how it worked. It was not until I learned Vulkan and my brain was just getting destroyed trying to understand Vulkan and how that maps to hardware or anything. But yeah. If you want to learn more about GPUs, I've got the perfect set of videos for you. And if you are a Gen Z like me, you appreciate the videos. ARM, Mali, GPU, training series. This isn't just about training you to write for the Mali GPU. They also go about how desktop GPUs work and how they differ to mobile. And they did it in a really nice way. I think you only really have to watch 7 of them. Well, have to. You can watch as many as you want. But yeah, this will give you a good idea about how the GPU works. So again, it'll help you understand like what OpenGL does for you. Maybe. But yeah, it will help you learn like how you'll, yeah, and how they accelerate everything. Give it a watch. 27? No, just 7. Oh, you think? Yeah, I'm not 30. That's the biggest clue I can give you. But I'm nearly 30. But I'm not 30. Um, yeah, so another thing that I would need to do, so I guess I'm thinking about like this devlog now. I think we can get to, I know I definitely want a few things. So I guess let's have a bit of fun by just doing some debug drawing, and then we can dig into like the rendering equation, and then put comments on this code that sort of reflect that rendering equation, I think. We want to document some of it. Yeah. So basically, in the past, although if you're interested in learning what we did in the past, there is a VOD channel where you can go back and watch all those VODs. We did some debug drawing. So we've got amazing Draw 3D and Draw 2D API. So we can draw like vectors and stuff, boxes. And we can do it in CPU code and shader code. This is going to be easy to do in CPU code because what I want to make is effectively a kind of like, I'm doing a presentation, right? But I just want to do a clip of me showing some, yeah. I think I might have my keyboard keys programmed to these. I might not have any more than 9, so maybe it's fine. But we'll effectively have a way of, yeah. We'll have a bunch of little scenes demoing sort of how light works, basically, with a bunch of arrow like vectors. So I think that'll be fun. So let's go ahead and find where we put our globals in. Frame start. I think anywhere here is good. So here is where I want to put my sort of like, we'll wrap it in this so we can always just wrap it in that. So we just try a little bit of a Draw 3D. Draw 3D vector in world space. What I would like to do is put 1 as 0, 0, 0. And I'd like to then put 1 at, say it's 1 vector of 1, for instance, for now. Then I forget the rest of the things. Thickness, 0.01, I guess. Color, let's do it white. And then do you want to Z test it? No, we don't, because we want to see it through all of the walls. I need to make a playlist. I don't know, because I'm going to be doing this project for a while. The playlist is quite simple. You want to see it? No, I'm joking. We want videos. That one started off on the wrong one as well, damn it. Oldest. There we go. And it'll play through all of them, right? No, it won't, will it? Damn it. Maybe I do need a playlist. That's 100 videos. And every time I go and press the edit button. I think people can find them. This effort. Yeah. Mickey Mouse. Right, so let's see if this vector actually draws. I think I tested it on the CPU. It definitely works on the GPU, so let's give it a go and see what happens. Right, do we see the vector? No. Should be somewhere here. Damn it. What is going on? Let's make it bigger. Let's say make it 5. And let's make it 1 thick. Damn it, the CPU one's not working. Is it because they already got uploaded? Yeah, here. So we put them in here. We should be able to just simply... Oh, things are flickering like mad right now. That is not good. Why are they flickering? Oh, did I not... Is the draw words wrong? That's right. Let's compare it to the GPU version. Right, we've got 9 words. Thickness, color, thickness, color. Insert index, count. I think it's alright. Yes, I don't know why this one flickers, causes the screen to flicker. It causes the whole display to flicker. Why? So we see the cone, right, and the arrow. Even the UI goes. Right. Even the UI disappears. Where's my draw 3D? Render draw 3D. The depth texture will be fine. Alright, draw 3D render, what does that do? Right, so maybe it's always doing a hit somehow. We go over all the words. G-draw words. Error over where? I think it's copying it okay. I think it's copying it fine. We could try a different one. Oh, I did this from GPU, it worked fine. Right, so this doesn't cause a flicker drawing that. Right, so that doesn't cause a flicker. So it must mean that the way we're copying it in there or something like that is just painfully wrong. Right, where's the draw vector? Right, let's copy this one in and see what's different. So this is the CPU one, the other one's the GPU. Right. So do the insert. So it has to be different because one puts it into some global CPU memory, whereas the other one does it into a buffer, GPU buffer. So as we translate view from world. Is view from world set yet? Question. Yeah, view from world might not be set yet. But then why is it working for the other one? Probably not it, but we'll check it in a bit. Yeah, it all seems fun. But yeah, so maybe view dot. No, view from world is set, it's fine. Damn it. Let's put the both of there, see what happens. Yes, it flickers now. Because I got that arrow there. Weird. Let's change the order. It looked fine. My nested loops. Oh, this one. Yeah, it was just debugging code. It was just me. Yeah, it's messy. Yeah, I'm just if I'm just chucking stuff in for prototyping, I don't mind it being messy, but I do go back and clean it if I keep it. Yeah, just saves the time, you know. I'm super confused. So the sphere one works fine. But the vector world space one does not. So the vector one is 9 words. allocate 9 words, count. Right, you get it in a local. Add it. You set the first word to have z-test in the top and count in the 16 to 31 bits. And the low bits where we store the type, I think. Yep. Just like the header, and we return the address to that. That's all legit. So we all the type in the header. We put those in. That was all fine. Put the color in there as well. Nice. So yeah, that should all be fine. Let's take a look at the shader. So the shader's going over here, and if the length, so it doesn't hit it, just goes past it. There's a color, isn't there? Closest hit color, I think that's what we use. Yeah, the closest hit color is, yeah, then it's gonna render something. So I think this is just happening. For some reason. I think it's rendering the hit color basically. But if you look for vector, the hit color only happens if length is greater than or equal to 0. So greater than 0. Oh. Wait. Yeah, if we're going for greater than 0, then it's going to use that and do the reverse, these boys and girls, and if you get hit. And then it unpacks the color and puts it in there, so it would just be white if it did a hit. Yeah, I don't think it's anything to do with this though. Well, like a maths book, have we gone through one? No, not really. I'm not a big fan of books because they take forever for me to read. I'm not really good at reading. Yeah. Man, why you flicker? This is meant to be a simple task. What have you done to me? Oh. Ah. I know exactly what's happening. Well, not exactly. I think I have an idea of exactly what's happening. The sphere is not rendering when it goes black, right? Oh, it's just the cone that renders. So the rest don't. I think it's something to do with the... Maybe I'm wrong, but this probably gets written to somewhere. Like this will get written to... Wait, or is a synchronization code? Wait a minute. Okay, a good place to check is this, but first. But actually, if just the cone is rendering, just the cone renders. But then there's a whole other part to it, which is like the yeah. So I think we can debug it by outputting like a color, basically, based on some variables, and we should be able to do that. But so let's look around here quick. So anything that touches this memory, well, no, not really. There's only 2 places, and they just read from it. Oh no, so this one writes. But yeah, we never call this. Uploaded, it will come from And it's been uploaded. It's saying it's... Yeah, I think this value is fine. So the way we can test it is basically we set closest hit color to, well, we set the red channel. Oh, we'll set everything to be this turn into a float. Something like that, right? So turn into a boolean, then turn into a float, so be 0 or 1. So we should get a white screen. But it flickers, right? So when it flickers, we still get a black screen, meaning draw count is actually 0. Right, that seems to make sense. But let's have a bit of a play around. Maybe it isn't equal to 0. If we put 1 into here, I guess closest hit color has probably been set afterwards to something else. And we'll see it. Yeah, okay, that wasn't a good test. We should move it after. Yeah, but then you won't see the drawing. Yeah. So it is going over the words. But I think they're a bit corrupt. They must be corrupted for some reason. Are they corrupted? We could debug it in RenderDoc and see what they get there. We could take 2, look at the buffers, compare the buffers. They should be fine. So when you look at a very specific angle as well. Okay, let's RenderDoc this. And let's go ahead and launch. So it's going to do a capture at boot. There you go. Let's move it a bit. Capture. All right. So if we take a look here, let's take a look at the where we did the render. Somewhere here, I don't know. Draw 3D buffer, that one. So if we click on that, where you can't load the captures at the same time, you have to open up in another instance. So do the same thing again. Or load the Draw 3D shader. Draw 3D buffer, view contents. So see if they're identical. Yeah. Right, they're slightly different. For some reason they're slightly different. So they should be encoding 0, right? Draw count should be... The draw count should be reset every frame. Yeah, it's not the... Yes, the reset every frame, that makes sense. Based on how it works. So we go to the draw 3D vector. So that implementation encodes, so a word is a 32-bit integer, each word is a column in here, right? Word, 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 word. So the first word is the header, it's got the type, right? Okay, then position. Position is next 3. Those should all be 0. Oh, it's got the sphere in it, damn it. Still though, the sphere should all be 0. I'm confused. Oh no, we transform it into view space from world space. Right, that's not gonna be helpful. Yeah, that's not gonna be helpful because I have to move the camera. Okay, so I guess what's happening. So eight of them is for right. So this is where the other one starts. We got 9. So we should have allocated 9 here. 9 words. The sphere would have put in. Sphere puts in 6 words actually. Let's double check that. So sphere is 6. So these are for the sphere. 4 and these 2. Then there should be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that FFF is the color. That's correct. Yeah, then the first. So the problem is we're seeing it all in view space. View from world. This is all the same code that runs CPU GPU. Maybe it's my. Say if the thickness went to be negative. I'm trying to think what's the difference. Well, we're doing a length here. So that's not the problem. Maybe some of the mask code is slightly different and it's causing a bug. But yeah, so we're doing a length from the sphere one, that works fine. But in here we're doing a mol P and a mol V. So the mol V is maybe missed. The way we can check that is if we just hard code it. Right, I've got some more ideas now. So if we just make comment out of this one, just make vec vec. Let's try that. Does it flicker now? Still flickers. What about the mol P if we stop moving that one? Wait, that compile. Yeah, so you're just seeing it in front of the. Okay, it's the mol P, I think. So what you're seeing here is you're actually seeing the vector cone because it's in view space. So you're seeing at 0, 0, so you're just going to see it in front of the camera. So the mol P, for some reason, it flickers on CPU. So we just comment that out. You'll see position and the yeah. Yeah, so we're seeing it flicker now. Hey, Master Agent, how's it going? How you been? That's causing a flicker of some kind. Very strange. Why do it cause a flicker? Why would changing this? The U32 words. When you look at a certain way, it then messes it up. Zero then 5. But this is like ran on GPU exactly the same. Oh no. So that view from world is just set earlier. If trap mouse, so then it's not updated anymore. So we, okay, it flickers still. I guess we could hard code the position. Let's hard code it to like 2. So it's still in it, or it's still flickering. Um, yeah. Um, so I guess we could try. Well, it has to be thrown into here, doesn't it? We could print out the view from world, and that could give us. Why don't we print out the valley? Maybe this can give us the insight that we need. Pos.x, pos.y, pos.z. So we've got to turn off the profiling, because the profiling is going to spam too much stuff into the console, and then we can't see what is what's going on. So yeah, so I'm looking at the value in the bottom left, and I can't see any obvious problem with the position that's thrown in. So huh? I'm still puzzled by this one. It's going really well. I almost got a fully featured build system in place with preview ghost build stages and such. Awesome. I hooked in the inventory system and interaction system into it. And now I'm setting up a new ping system which allows for building process to request nearby entities to bring what's needed. Awesome. Sounds like you've done a lot of different work. That's cool. But I've set things up so it'll be figured anyway easily. Awesome. Resources per stage, if configured, effects per stages, etc. Nice. Sounds like a lot of work there. Awesome. So remind me what your game is again. I may have forgotten, but this is the one you wanted to do in like 3 months' time, wasn't it? Yeah, I don't know if it's Z fighting because we're just drawing it on top. Hmm. There is a Z test bit though. Maybe it could be. Like, I hope that turns into something sensible like E32. Should do. Yeah, ain't that. But yeah, we could look at the. So Z test depth. Why don't we just say. Do that for now. Yeah, so still, yeah, it's nothing to do with the Z testing. Specifically. Vector and wall space. Still confused on how this is not wanting to work. Like, if I comment this line out, the position that gets thrown in there is fine. I guess we can try it from GPU as well. We can actually just put the same code in. Yeah, that's what we'll do. So I've got one called frame initialize. We can take that same. Right, so let's take this line here. There's one called frame in it. This is just a shader which runs once on the GPU. So I can just put whatever I want in here. I'm hoping that. Oh, that still flickers as well? So just the cone shows. Let's remove the sphere one for a moment as well. And let's see if it still flickers. Because I've used the vector one before. Oh. I literally used it not long ago. So it's somehow broken. I have not changed any of the code. I've updated my compiler a bit. But I don't think any of those fixes should have caused this problem. Very strange. Yeah, 2 months because you'll see about a month gap in between. I was searching for jobs like crazy that month and had some interview tests. Cool. But I'm working on a group of toolkits for different fully featured games. Basically, your bootstrap kit for anyone who that was laid off like me during the last 1 to 2 years. Yeah. Awesome. That's cool. Do you reckon it's divided by 0? Maybe. There are a couple thousand more people on the market now. Wow, yeah, it's insane, isn't it? If you give them a big head start. Yeah. Yeah, that's cool. I'm glad you're sort of trying to tackle the problem as well for other people. That's really great. Yeah, it's a very crappy situation. Things have sort of homogenized, isn't it? That's the way of saying it. Everything kind of went together into these big companies, and lots of smaller studios got bought out, isn't it? It needs to be a lot more smaller, independent studios and medium-sized businesses than them. Is it a divide by 0? If we move the position off to 2, we still have the same problem. Yeah, but we're not dividing by that position. Also, just saying. Right, so I guess we can check the shader code now. I guess it is just. Draw 3D, here we go. So, right, length greater than 0. So I think we should be able to set the hit color based on. So let's set the hit color to be white. Because we have length is greater than 1. So every pit, it should have a white background. You know what? Let's not do anything too crazy. Let's make it gray. Thank you, Cecilia. Yeah, so we're seeing. Interesting. So all of these are going through in that if statement. This one is not. How's that cone getting rendered? That's the question. It'll do the hit. So I guess we can just do debug prints. I don't know why I'm being so silly. We have, we can just print on GP basically everything that we want. So let's just go and do that quick. It is going to be per pixel though. So what we would actually want to do is put that in a nice if statement, where we just say if. So for the top left pixel, every pixel looks at every debug shape. So this is going to be fine. Yeah, we'll just print out position.x, position.y, position.z. So let's look at the thickness as well. Long link. Yeah, this is Stone Rule. This one is 16 minutes in. But yeah, Stone Rule will release stuff like every month. They got some good stuff. I highly recommend. Does one thing fail to render because everything after it? Let's render it with your. So the reason is because this shader here, draw 3D render, this is the second last thing to run. The last thing is draw 2D render. But these are debug drawings and we just put them on top of the scene. So what happens is, from my understanding at least for now, is if the closest hit color alpha is not 0, then it will put a pixel out on the screen. So it's just putting out black on the screen basically. Over everything else. And I don't know why. So I think it's floating point precision. Right, see these boys and girls and see what they say. I thought I disabled that profile. because I won't see any of the prints otherwise. Cool, so these are coming from the GPU. And when it flickers, they're still the same. Yeah, so when it goes black, it's still just a little bit off. Right, so at least you're able to see something now. So we can just keep adding more print statements and understanding more. So the next one is, like, do we go into here basically? Can we say print a cone length? So we see cone length, then we are actually going into here. Is for the bottom left pixel, this one. Shoot. Oh, I didn't put it inside one of these. So it was filling up the buffer. Yeah, greater than is probably a good idea. Right, cone length is still triggering. Yeah, cone length is still there when it's black. So, alright, so we are going into here. Raw pixels. Wait, that makes 100% sense what we're talking about. So the one that has the problem is the capsule. So I guess if I comment out the capsule code, does it not make everything else go horrible? Let me remove that line there, because I was adding a color anyway. Does this fix the flickering? Okay. We fixed the flickering by not rendering the capsule part of this vector. Right, so what is the So let's analyze the inputs. Get these boys and girls here. So we've already got thickness. Let's get a bit of a cone start. That would be more of like one of these boys here. Right, nearly there. And we can do some lovely debug illustrations. Capsule start could be a problem. You don't think it's the capsule? Ray direction is probably the last one. Right, let's take a look at all of these and see what happens. Ooh. Yeah, just never enter the capsule again. Easy peasy. Right, so it's flickering. In view space as well, so the ray direction wouldn't move. Capsule start and cone start will be in the same place. Is that what we want? So if I adjust the thickness, right, if we modify these just a little bit, is there a min or a max somewhere? Let's reduce the cone thickness. Wait a minute. Wait, it's not about the cone. We're talking about capsule. What's thickness? Right, so if I make that thickness a bit smaller. But it was flickering even when it was really small, right? I think. Okay. So this is probably why we... Right, so there's something to do with the way... When it does the capping... Yeah, when it caps the... So this is fine, it doesn't cause any flicker. So what's causing flicker is when the thickness is too big, then it has to cap it. And then it's causing... where is it? It's this one right here, length divided by 8. So is equal to length divided by 8. And then we times this by 4, and that's cone length. If cone length is bigger... then the length of the vector, which is from going from the start to the end, isn't it? Oh yeah, just the vector. Why does that change the thickness? So if the cone is bigger than the length of the... So you have the cone, then you have this vector part, right? So if it's small and like that, we're saying if this isn't that big, or isn't as big as that length there is not as big as that length there, then make the thickness of this be length divided by 8. And then the cone length is thickness times 4 again. Right, so I guess you only really have to do that there like that. Whatever. And then the cone thickness. And then we use the thickness here in cone length. Right. Maybe I need to simply change that a bit. Does it flicker now? Right, it still flickers. Maybe it isn't anything to do with that. Maybe divide by, I don't know, let's try 16. Yeah. Right, maybe that isn't to do with that. So capsule versus ray 3D. PAPB. Right, the capsule start to cone start is the length of that is not as big as thickness. Yeah, so the thickness has to be... Okay, so there's another thing we need. So this thing here, we want to say if the length of capsule start is there a way we can get the length some other way? Thickness take cone length. So you've already got the length of the vector. So is any of length less than, sorry, take away. So length of the vector, take away cone length, take away thickness. I guess if that is less than 0, I think that's right. Then what you want, so if that is less than 0, you actually need to change I don't know if that's what's happening. The thickness is just really big. Yeah, because it might be going into the... So we're looking at here. They are basically the same value. So there's basically no difference in them. So... yeah, the way I'm doing the size is something weird about it. Maybe this is not what we need. But yeah, we put in like a value of sort of 5 thickness, or yeah, I'm not sure if the length of the vector should determine the thickness. Yes, it's the cone. Thickness times 4. Yes, it's mapped to that. Yeah. So let's look at thickness before and thickness after. There'll be 2 thicknesses. Let's see how this looks. So it's the same. It has not changed. 1.7. Yeah. Hmm. Hmm. So we move the screen a bit. See these a bit better. Yeah, so when they're identical, when these are identical, it doesn't show the capsule anymore. So the capsule has a length of 0. How do we make that be a thing? So capsule start is position plus the thickness. And then this is, the end is that, take the cone length. Maybe we can take away the thickness here. And that might be enough to do it. I wonder if it'll mess up some of the rendering though. Okay, that's removed the... Yeah, we don't see the capsule through the tip of the cone. So maybe that's the good enough fix. Right, that's a way longer than I hoped for, but there you go. That's cool. So that's from the end. Yeah. Okay. Right. So the next thing we want to do is actually do some debug drawing. We're going to make some... we probably want to model how that diffuse one is calculated like the hemisphere. Yeah, so we want to make some little examples when we do that video. So there we go, got our vectors back. They don't flicker anymore. Alright, so I'm just going to take a quick turn break and refill this drink here. And then we'll carry on with that one. Right, BRB. Right, welcome back everybody. So the first illustration I would like to do we call it illustrations? I don't know. I'm not drawing it. I'm drawing it with code, I guess. But the first one we want to do is that diffuse. I didn't actually do those renames. Yeah, the irradiance map. I want to draw out sort of like, so what that shader does. So basically, we'll nick this and we'll just draw it. So the thing is about these, we probably want to do a switch statement, I imagine. So yeah, just a bunch of like test code, which is just gonna basically debug draw some shapes, and so we can just use that in the dev log. So where's the ray sample vector? Right, up and right. Normal, I need those. So the normal is also just going to be directly up. Yeah. So we should just be able to do debug draw from the position of, I guess, 0. And we're going to go draw in the direction of sample vec. And then if we just delete all that, voila. So that should draw us a bunch of little vectors. And it's going to look cool. We'll sort the colors and everything. But wait, things are very slow. Clearly too many vectors here. Yeah, I remember now we did actually change this number. Yeah, so clearly too many vectors there. Let's give that a go. Just got a black screen there. Bit confused there. So let's comment out this. It was running. Okay, so something is painfully wrong, and I don't know what yet. Just got a black screen. Is it that silly problem again? The problem is it's going to render far too many. Let's put a break in here. Just so there's going to be 2 in there because I remember there was. Get rid of those. So let's look at that capsule start and cone start. Right, capsule start and cone start is NaN. Why are they NaN? Because the vector itself is NaN. Bum bum bum. So, okay, good to know. So the thing is, if you have like NaN and that, we just shouldn't be doing this. This definitely needs to be safer. Position is NaN. So position or inf. since it's debugging code, we should definitely be a bit safer when it comes to some of this stuff. So yeah, position. Wait, those are times 3s. And you kind of want like any. Alright. So position vector, no end is fine. Thickness, that's another input, then length. But really what we should probably do is like, rather than doing it in the shader, we should probably have that done CPU side. Yeah, maybe we should move this to the CPU, but I guess let's just get it in here and then we can move it. Oh, not to the CPU, just when you punch in the actual, when you go to feed them into the buffer. Oh yeah, these aren't times 3s. Right, there we go. So that shouldn't make it a black screen now. They're just not showing up. Cool. Right. So, yeah, so CPU side. Why is sample vec NaN? What did we do? Is it because the normal and the up vector are exactly the same? Yeah, so they're identical, isn't it? So let's do 1. I don't know. Not going to be correct. Let's do 1.1. I should have done epsilon, isn't it? Still slightly incorrect, but it should be alright. There we go. No? It's probably still NaN. No, the cross product of things that are in the same direction. They might get you an NaN. What will they get you? Yeah, they'll get you like a 0 vector, isn't it? Kinda. And then you're normalizing it. So you take the length, it'll be 0. So no. Yeah, so yeah, so 1 divided by, that's your length. So the cross of those end up being basically 0. I think at least. Let's do a different normal. Let's see if we see it. Yeah. Right, so seeing a bunch of vectors here, they're very small. We made them bigger. But yeah, there's a problem with a cross product. Like we need like a safe normalize, basically. Somehow. But yeah, let's make them bigger. So sample vec just needs to be multiplied or scaled by something like a 5. And so we should get a nice bunch of arrays there. Here they are. Yeah, so these are all our sample arrays when we do that diffuse or that irradiance map. So we do that for every single, what do we do it for? Every single pixel on the cube map. We'll draw a normal to it. And then, yeah. Like a double one there, which is weird. Oh, that's just because the right, the way we changed the for loop is not perfect. That's cool. Right, I've got me some ideas. But yeah, so will that work? Will that get us directly up? They don't show. But yeah, something to do with the cross, and then cross is the normal with the right vector, and then like it becomes NaN or whatever. I don't know why I'm doing this. So maybe we should draw lines to like an actual pixel as well, and show the normal, and then yeah. So this is just, yeah, that's cool. So maybe we can simulate like, hey, there's like a cube map at a particular size or something like that. So maybe the cube dim is like 10. Then if we draw the cube, the problem is, no, you still see the stuff inside because there's no Z testing. So we can draw the ABB. Center position 0. Cube half dim. And then I guess we should really do a different color. Let's do cyan for now, since it popped up there. So I think what we can do, oh shoot. The most annoying thing is you don't see anything. Why don't we see anything? Oh, 0.1 in size. Very small, maybe? No, what's this? Oh, border thickness, interesting. Oh, what is this, ABB? In view space. Damn it. Oh, ABB. So, view from world. Because I've been view space, access line bound box. So let's try that. Nice. So we got our box. So I'm thinking like, yeah, so why don't we start our camera back here so I'm not moving around all the time. We can build these illustrations here, so I can just boot it up and we can just talk about it. And when I want to talk about these, I can just fly up and just look at it. But yeah, so let's sort that out. It's not too hard, it's just changing the view from world. There's a starting position, it's here. So we'll leave the old ones in. I don't think we need so 0 and they could just move back a bit. Well, that's forward. Let's move back by 10. When it comes to rotation, there's going to be no rotation. I think that should put us in the right place. Right, a little bit further back will do. We could say 20. Awesome. So this is our cube map. When we're trying to talk about the how we build the irradiance map. Nice. Maybe it could be a bit bigger. Maybe we can make it like, I don't know, 16. So basically we're going to have like a pixel. So I guess we could cycle through a few pixels and we can have it on like a timer. Where it would just go to the next pixels. So we could probably have these pixel locations. And we'll have like maybe 3 of them or something like that. But they'll point to different... right, so let's just say it's pixel location. So the dimensions of the cube, I guess, should really be in an integer. Yeah. So this way, we want something from about... we imagine it as very low res cube map. Shoot. We have got actual dimensions though. So the thing is about that specular version of this, it uses a full screen resolution one. But yeah, I don't think I want to go into too many specifics. I just want to articulate the general idea of what's going on with some kind of visual way of just understanding it. And I guess the details can be learnt from there. I'll link to other things. So let's just say this one's at, wait a minute, it's a cube map, isn't it? Yeah. So we'll just say it's at, let's say the first one is in the middle, so 8, 8, and then at the top. So that'd be cubed in. The problem with that is that it's not going to be in the middle, so it's got to be 0.5. Oh, wait. Yeah, it's kind of relative, isn't it? So 0, 0 cube, right. So the problem with that is it's not going to be perfect. No, this would be a problem with the norm. So we're going to give it like a little epsilon. So the next one, we can say it's like, a few pixels to the right or whatever. So let's say 6 or 4 maybe. And we'll say it's like, maybe we can move it towards the camera a bit by making it like -2. And the final one can maybe be something like going down and to the left. So it'd be like negative and negative. So yeah, that's interesting. We can flip it. So now we've got these pixel locations. Basically, we can have some kind of like, hey, what sort of pixel lock index are we? And that obviously starts off at 0. Then you effectively have some, you want it to tick every so many seconds. So we need probably like an accumulator, which starts at 0 again. Every frame you increase the accumulator by time by dt. Then if accumulator is equal to maybe, so it's in seconds. So this one is equal to 5 every 5 seconds. Then what I would like to do, from there is so the pixel lock index plus equal 1, and then you mod it with the array count of pixel lock. So with that, we can basically, I wanted that to be a float. It's cool. That's to work out. Yeah, so now we're doing that, which is fine. Now I want to get out our pixel location. So our normal is actually just going to be pixel location normalized. Pixel lock index. So we try that one out. We should see a nice moving illustration of what's going on. We should redraw the vectors. So every 5 seconds, it should just change. Oh. Right. Stuff is rendering. The box, though, is not transparent. We could make it transparent. We don't have any blending, though. Yeah, it's just closest hits. So yeah, it's always based on the closest hit. So the way we get around that is we just give it a border. We give it a border of 1. Yeah. It's too big still. Why is that too big? It's flickering like crazy. Three, 4, 5. Oh, I didn't reset the accumulator. Whoopsie. Right. Whoops. Yes, this one's going to be... Okay, so that was pointing forward. No. Right, so... At the top. Then I want this one to be at the top, but a bit further back, pointing towards me. Then this one has got to be... at the bottom. These should be half dims. There you go. Raw OpenGL? No. This is Vulkan. And I got my own custom API on top of that. It's abstracted. Alright, so that's kind of nice. And we're showing how you point to... Yeah, you do a hemisphere. So the problem is... I should really just move it forward by default. And we should really draw the pixel as well. Just draw a box. Pixel lock. But yeah, just to give you a bit of an idea on the project, protein, or protein, I guess. We have a GPU layer, so it's compute only. So we're doing everything in compute shaders. So it's basically just ray tracing for 3D, and then for 2D we do basically sun distance fields. So our GPU API is like 300 lines of code, and that includes, for the header file only. That includes the texture viewer, profiler, dispatching compute shaders, and some texture clears, buffers, buffer clears as well. Read back API, upload API, and creating buffers and textures. So that's all the GPU layer does. And then our graphics is built on top of this, where it just launches compute shaders and does stuff on buffers and textures. So we should really draw that little box. That'd be nice. The box will go into the center location. And then the half size would just be 0.5, because it's half a pixel. Well, it's not anyway, in this diagram, which is only 16 pixels. Yeah, 16 pixels for this cube map, 0.5. Obviously half a pixel. So we need to move stuff pointing towards the camera more. Yeah, stuff needs to be pointing towards the camera more. So we should probably make it point like towards me, 4, -4. So it should always point towards the camera more. Oh, for crying out loud. So we should see the pixel being drawn as well, not in cyan though, that's a bit silly. And we should have an infinity on that. We should draw it like a green. So just be a box rather than a bordered box. Right, so there's our pixel that we're drawing, and it's pointing towards there and then it moves. Right, that's cool. There's running that pixel in the cube map. The last one didn't really work. Right, so that's a 3. Yeah, more 3. Weird. But yeah, I do like that. Although we do want to have probably another vector. And this vector is going to draw the normal. But then, well, it's probably just going to draw a vector towards that, to be honest. And then thickness, probably the same. I'll probably just want in red. So let's see what the issue is again. On the third one, it just doesn't. Yeah, maybe I should make that a little bit smaller, not gonna lie. Yeah, so drum. Oh. Damn it. Yeah, something happens with that third one, it's super weird. That's 8. -8. Oh, it's an unsigned number. And then it goes to something high. Then converts to a float. Alright. So we should already make this a little bit smaller. So we should just scale all those boys and girls by 0.8 or something. And that should be that illustration mostly done. I think I got all the things in, just probably want to change the colors. Yeah, so we're saying we've got this normal points towards the pixel that we're trying to, yeah. I could do a random one, and then you get more, but you kind of want to do random, like as if you're only just going around here, like basically. Um, you kind of, so say if we just did random, so every 5 seconds, rand, you could set, you could decide on um, I guess you just decide on the signiness x. Y minus 4. Yeah, equals to minus 6. So you always want z to be minus. That's the thing. Then you decide on the signiness of x and the signiness of y, and then which one of them gets the cube half dim. It's possible. So by default, you set it off at, you put it off at like 6 or whatever. And then instead of having those hard-coded ones, we've got rand, right? So you say rand 0, 1. So pixel lock. We'll make it static. So you're saying, hey, the x component, odd or even basically be a minus 4 or 4. Same for the y, beat it separately. Then you also want to rand. Oh yeah, then the z is always equal to like minus 4 or something like that. Maybe minus 6. Well, it could be arranged from minus 6 to minus 4, 6, I don't know. And then based on this random number, it was 0, 1. We want to basically store that half dim into it because it has to be the edge of the cube map along the x or the y axis. So this one will be pixel lock.x. This will be the y one. So that should actually allow us to remove all this. And it should be perhaps better. Let's have a look. Yeah, so we get a random one now that is towards the camera-ish, right? 6, but not 7 or 8. Wait, 7 is probably the last. Yeah. And it's going to randomly pick one every 5 seconds. It's just going back and forth. Okay. C's random number generator. Wait, I'm modding body. Why hasn't the X gone odd yet? Hey, Cranston. Oh, the X went odd. Finally, not random number generator. Yay. Hey, random question. Does anyone know an elegant way of producing a diagonal matrix from a vector? Oh, a diagonal matrix. Using PBR functions without having to write all the components. Thank you, appreciate it. Yeah, still some tweaking to do, but it's getting there. Yeah, I'm not really sure, to be honest. I can't really help you there, Cranston, but I'm sure there's a maths person lurking in the chat. They're always there. I just have to say something insanely incorrect and they'll show up. Like, yeah, sine returns a number between -5 and 10. Just wait, they'll show up. The square root of 7 is 100. Any moment now, there will be a maths person that will show up. Just you wait. Yeah. Yeah, please, someone help Cranston there. But yeah, this random number generator sucks. We probably need to seed it. I should have seeded it, right? Wait, well, time. I don't think I think you seed it once at the start of the program. Rand. Oh, I forgot. It's just called seed. No. I need to remember. It's Rand. That's it. Rand. Right. With a bit of time. That might make it better. Because it wasn't seeded. So it's just doing a bunch of crap. So every 5 seconds we should get it go on the left, go on the right, go up and down. Yeah. And then she goes to the left maybe. We went to the exact same spot. Yeah, it's at 4 though, isn't it? Why is it never going over to the left? Right. I've never seen it over here. So there's something wrong with my Y. Where I should just have a hard-coded set of integers. Yeah, that's Y -4. Right, it's happening. Y negative. Wait, you'd never see it. Oh, hold on a minute. This also needs to be. You need to have the copy sign. Right. I see now. Right, give me. X, Y, X, Y, X, Y equal 4, X equal 4. Right, and then we can just feed that into here. Negative X positive x. Yeah, it could have been written better, but it's just demo code. So I'll do it proper. Thank you, Olin the Mage. Appreciate it. You wouldn't happen to know about a diagonal matrix, would you? There we go. It's going down there now. Right, so it's shooting over the hemisphere. So you're collecting all the rays. Yeah, cool. Yeah, I think that's cool. So you're trying to render for that pixel in the cube map. You'll sample all the cube map and then average the color, put it in that pixel. Nice. Easy peasy. So should we monkey with the size of the vectors? So let's make him 0.05. Bit thinner. So right, so is that worse or better? I like them a bit thicker, to be fair. Maybe do 7.5. Thank you, Mel. Maybe scale the vectors on the same coefficient you weight the samples by. Interesting. Ooh, so you mean by you weight the samples by. Yeah, we multiply. Yeah, it'll be weighted here, wouldn't it? That's a good point. So yeah. That's a good memory. Thank you though, Cranston. That'd be a good idea. So what you're saying is you can change the length based on that. So that would be yeah. Although you don't want it to be yeah, this should never be 0. I think. Oh. That already changed everything. They obviously need to get a bit bigger there. So let's make 25. Way too much. 20. Probably monkey with the colours a bit as well, make it a bit more pleasing. A bit too big. They're going to change. Oh, interesting. Unclear of what, if that made the better or worse. Yeah, the hemisphere, yeah, is a bit. Yeah, you can't really see the hemisphere too easy, can you? That's the downside to it. You're just seeing more line. But yeah, I guess, yeah. Nice idea though. Yeah, I think we should just undo that at least. Yeah, so I guess what's left is just maybe monkeying about with the colors. The thickness is probably good enough there. Yeah, we've got a few more illustrations that I want to do. I want to do the one where we calculate the sample. What's it called? The sample specular pre-filter map, where it does a similar thing, but for the specular highlights only. So after we've got this one perfect, there's another copy paste of this and replace it for the specular code the way it does that. We probably want to do a couple of illustrations to do with how roughness works and how the basic PBR, you're not simulating the microfast, that you're estimating. Yes, sorry, you're approximating it. That's the way. So yeah, we'll do illustrations like that. So it should make it easy for people to hopefully understand what I'm saying. Oh, with colors. That's a good, yeah, maybe. Yeah, because it is a cool, interesting. Colors though. Sine cosine on the color. It goes impact, right? So you can probably do it on the XY. Yeah, so red was the other one. We could do this on the green channel. The more green it is, right? Green, oh, maybe. You could maybe remove the red channel and just make it white. I don't know. GPU linear to sRGB. I think that's right. Oh, then I got to pack it. Pack into a int. Yeah, let's give that a go. See if that looks better. Yeah, so the ones that are not white are basically weighted less. Yeah, there's things to play about with. Yeah, I think that looks better. Yeah, so the reason is, now that I think about it, is because they get that perfect, if the light comes from here and it bounces off a surface here, the ones that are more white are the ones where you get that perfect reflectance, I think. So those wouldn't get it. These wouldn't get it either. I think that's the way it works. It's with a half. Or it's where the half vector is. Yeah, something like that. Yeah, that was really cool. So next stream we're going to carry on with one of these visualizations. We should probably get all the visualizations done next stream. And we'll probably be working on going over the code and probably looking at the rendering equation and put some comments in around that and trying to understand that as well. Yeah, So just basically preparing for doing a good devlog on PBR. Cool. That'll be Tuesday. Thursday we'll probably do the devlog. Sunday next week, we might be moving on to the next thing, which would be BVH, potentially. I think the cosine term is from the Light model, Lambert diffuse, and the sine is to compensate for sampling density. Right. Interesting. Hmm. Okay. Right. I need to get going now because I've got to roll into bed sometime. So let's find someone to raid. So Tuesday, 7:30 p.m. GMT +1. Same time on Thursday, Sunday, whenever this stream began. Back then. Still look through your speculative odds, but given the above, I guess the weight would be the weighting would be it's very different. There's like an important sampling thing as well that you have to do for it to look good, and sampling from different MIP levels it is really different. If I just show you the map. So the diffuse one is actually a very small. Here's a texture viewer. And apparently my debug shapes draw over my texture viewer. Let me move it the way. So the irradiance map, this is the diffuse one. It's actually really low res. It's 32 by 32. But from what I understand at least, is the pre-filter map should be the full resolution. So it's that nice blur. And this is MIP 0. But this one, actually, believe it or not, when you sample from it, it actually looks kind of you can still kind of see it as a mirror, because yeah, just the way it kind of works. It just, but yeah, as you get up the MIPS, it gets rougher and rougher. But it's a really nice blur. But you have to do important sampling, if not, it doesn't look as this good. So if you see my spheres, and if we make it metal and turn on the roughness, you'll see it's not that. It's a bit blurry, right? But it's not as blurry as that thing was. The texture was at MIP 0, but we're getting, when we're far away, we don't really get the jump in pixels. We're getting around here because of this anti-aliasing glitch. So ignore that. We don't get the jumping so much in the on the spheres anymore. So that's cool. Right, let's find someone to raid. I got a jam. Right, it's a C guy. TCAP. Sorry, TCAP again. Right, thank you for coming, everyone. I'll see you all in a future one. And yeah, have a good start to the work week.